Example 3.3. An electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, its resistance at room temperature is 27 degrees centigrade is found to be 75.3 ohm. When the toaster is connected to a 230 volt supply, the current settles after a few seconds to a steady value 2.68 ampere. What is the steady temperature of the nichrome element? The temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 to the power minus 4 per degree centigrade. First, we will see what are the given values. Yes, initial temperature is given, initial resistance is given. When voltage is this much, current settles to 2.68. Temperature coefficient of resistance alpha value is also given. First, we will find out what is the final resistance. Final current is given, voltage is given. So, by using Ohm's law, we will find out what is the final resistance. R equal to V by I. So, we are getting nearly 85.82 ohm. Now, relation between resistance and temperature, that is R equal to R naught into 1 plus alpha delta T. R value we calculated. R naught is given 1 plus alpha delta T. First, we will find out 1 plus alpha delta T. 75.3 will go to the denominator. 85.82 divided by 75.3 equal to 1 plus alpha delta T. First, we will simplify this part, that you are getting 1.14, that is equal to 1 plus alpha delta T. 1 will come to this side. 1.14 minus 1 is 0.14, that is equal to alpha delta T. Delta T equal to 0.14 divided by alpha. Alpha value is 1.7 10 to the power minus 4. This nearly becomes 824 degrees centigrade. What is delta T? Delta T is change in the temperature. That is T minus T0. T minus T0 equal to delta T. Therefore, T0 is given as 27 degree plus delta T we got 824. If you add, you are getting 857 degrees centigrade. Here, all the temperatures are maintained in degrees centigrade. So, final temperature is 851 degrees centigrade.